channel on reaction kinetics. Today's class will be talking about second order reaction and its half-life. A second order reaction is a reaction whose rate is dependent on the concentration of two of its reactants. So if we have a reaction of this way, reactant X gives us a product, let's say 2 moles of reactants here. So from what we learned previously, we said that the reaction rate R is equal to the change of X over the T. Let's use the general first. So, and also we talked about the rate law or rate equation. The rate equation is also equal to R is equal to, that is proportional to the concentration of X raised to power n. In this regard, n here is 2 because we are talking about the second order reaction. And if I remove this equal proportional sign, I'm going to have R is equal to K X n, where n is equal to 2. The K there represents our rate constant. So from here, let's call this equation 1 and this equation 2. And of course, I said there should be a negative sign here because the reactant decreased or reduced to form a product. So I can combine equation 1 and 2 to get negative change in X over the T is equal to K X raised to power 2. And if I do some interchange, some rearrangement, I will have that the T goes here and S comes down. Then we have dx over X raised to power 2, which is equal to K dt. And also decide to bring a negative sign towards the right hand side. Then I will have dx over X squared is equal to negative K dt. And when you have a derivative equation like this, to bring it to normal, you integrate. Integrating both sides, we have that integral 1 over X squared change in X. Of course, they are the same. They are both the same. Is equal to, we don't integrate negative sign and a constant, so they are brought outside. Then we'll have the T. So having done this, of course, to integrate 1 over X squared will give you negative 1 over X, which is equal to negative KT plus C. We usually add the sign C, a constant, after integrating all our variables. Okay, how do we get the value of C? To get the value of C, we say at or when T is equal to 0, our final concentration will be equal to our initial concentration. So therefore, we can substitute these values here. We have negative 1 over initial value of conc of X is equals to negative K 0 plus C. Of course, anything multiplied 0 is gone. So I'm left with this, meaning that C is equal to negative 1 over X naught. So having done this, we can bring back the value of C back to our equation. We'll finally get that minus 1 over X will be equal to negative kt plus c. The value of c is this, so c has a negative sign, which will consequently change this to negative sign. Then you have minus 1 over x naught. So this is the equation for our second order reaction. And I also decided to move this negative sign towards it. Then I'll have minus or 1 over x is equal to negative sign changes this to plus. You have kt, then changes this to plus 1 over x naught. Then that means by multiplying through all by minus, you get that value. So this is our equation for a second order reaction. Now, how do we get our half-life for a second order reaction? Of course, I said the half-life of a reaction or an equation. The half-life of any substance is the time it takes for that substance to reduce to half of its size. That means at t half, the final value of x will be equal to the initial value all over 2. So let's substitute this value into this. We therefore have that 1 over x naught over 2. I'm replacing this with x naught over 2, which is equal to kt half, because we're talking about half-life now, so we change the time to t half, plus 1 over x naught. So collecting like terms, I'll have that 1 over x naught over 2 minus 1 over x naught is equal to kt half. So I can also transform this to 2 over x naught minus 1 over x naught, which is equals to kt half. And then when I take the LCM of the both is also one of these. So this divide this, you get back your 2 minus 1 is equals to kt half. And of course 2 minus 1 gives you 1 over x naught is equals to kt half. So finally, making t half the subject of formula, we have that 1 over k x naught. So this is our final answer. So we have been able to derive the half-life of a second order reaction. Thank you very much. See you next in our next video. Bye. Hello guys, if you find this video helpful, don't forget to give it a thumbs up and click on the red notification button to get more of my videos. Thank you.